Good afternoon. And in the interest of time, I'll really rush through this presentation. But I do have hard copies, and if anybody is interested in reading it at leisure, I would be delighted to share a copy with that person. So basically, I'm going to talk about what are the factors that are going into the analysis post-Fukushima on the plant that we are designing, the next generation centrifuge plant that we are generating for nuclear enrichment. I'll briefly cover three aspects: who we are, which I'll really now fast forward. What is the American Centrifuge Plant, ACP, and how do we assure public safety? As you can see, these centrifuges are really fairly long. They're anywhere from 3 to 4 times the length of the next state of the art that exists in the world, and they are between 4 and 5 times more efficient than the next state of art that exists in the world. Again, I'll rush through there, but basically we are a multi-state company. I won't go through this one. Just give you an idea, this is the enrichment is a $8 billion industry, and as you can see, the global players are uniformly distributed between Riva, France, the Russians, Urenco, and Houston. I'll talk about our existing plant, which is based on the gases diffusion technology. This is a huge plant covering the roofed area is multiple sizes of the stadium. You need about 2,000 megawatts of power daily to feed this plant. 2,000 megawatts of power, probably maybe Mumbai's power needs for the whole day also. This plant is located in Kentucky. Was built by the U.S. Atomic Energy Commission in the 50s, and essentially we have lease rights to it as a company, and we produce about 6 million SWUs right now. It is a nameplate capacity of about 8 million SWUs, and we use 6 depending on the market conditions. I won't cover this. This is basically our program where we take some of the Russian heavy enriched uranium and blend it down to the LEU for utilities. Well, let me come to the American Centrifuge Plant, which is based in Ohio. Those buildings are not cartoons; they're actually there. And the facility was originally started by the United States government, and is essentially being transferred over to USAC under a 2002 agreement. And as you can see, the U.S. government, the Department of Energy, Atomic Energy Commission did operate it and has accumulated about 10 million hours of runtime on the centrifuges. And we have since done an upgrade. The department's their best machines were running at about 280 SWUs per machine per year. We have gone up to 350 SWUs per machine per year. So we have significantly improved the output, and those are some of the things that you can see. The plant in its current configuration will produce 3.8 million SWUs per year. Let me now address the safety gap, which is the issue that is in the topic. Essentially, enrichment plants are not the same. I'm sure many of you probably do know, but the fact is that we don't have a nuclear fission. In other words, there is no heat to dissipate. So even if we have our plant is shut down suddenly, there's not a issue of do we need emergency core cooling systems to dissipate the heat. We do have different procedures to address different scenarios. In fact, our current plant, which is the gases diffusion plant, did have a significant upgrade program as part of the post 9/11 assessments that the United States carried, which in turn actually turns out to be, as Bergman said, have done a great job in terms of even looking at post-Fukushima, those changes that were brought in post 9/11 actually are enhancing the safety of the U.S. nuclear infrastructure. The Piketon plant, we call it, is also using some of the assessments from that and improving the safety. And again, for those who may not be familiar, we do have license for the plant from 10 CFR Part 70. It received the license in 2007 for 30 years to construct and operate the ACP. While the recent Fukushima experience, as I said, doesn't have a direct impact, we do actually have some guidelines given to us by the Institute of Nuclear Operators, INPO. And as you can see, these are the 4 areas that generally the concerns have been expressed: the ability to mitigate beyond design basis events, ability to station blackout conditions, internal and external flooding events, and also the emergency response capability. So all those factors, in fact, are being reassessed and have been reassessed as part of our activity. NRC has already initiated a dialogue with the nuclear vendors in the area of enrichment technologies, and there's a technical instruction coming out. But in the meantime, the inspections have started, and NRC will complete that process announced previously on February 29, 2012. Our plant is relatively in a stable geological area now that as the centrifuges are building that house are designed for the worst case scenario. We have had part of the licensing process was to complete an EIS, and there are no major faults near the site. Nearest zone is approximately 25 miles away, and there has been no seismic activity associated with it. The largest earthquake was the Kentucky earthquake, about 70 miles away. It's a scale of 5.3, and the beyond design basis event goes significantly above that range. Now, in case a strong earthquake were to happen, the plant is designed to basically address those on a beyond design based events. And the last item is the centrifuges themselves are configured to withstand a significant impact. So it's kind of a defense in depth approach in our case. Also the outside containment of each machine. We have 11,500 machines when the plant is done. Each of them has the capability of basically withstanding such an earthquake. Now, that's from a regulatory standard. From an operational standpoint, we have an NRC-approved emergency plan, and the PSS, the plant shift supervisor, essentially manages each of those emergencies. The plant has significant on-site emergency response resources, which includes trained first responders, licensed medical technicians, firefighters, security officers, and like. If the damage is created from the earthquake's potential off-site effects, the emergency sirens will come on. I mean, this is pretty routine. In the worst case, the neighbors living within 2 miles will be advised shelter in a place, and this is always goes to the drills, so they actually already know where they're supposed to be in case something like this happens. And there's, as I said, there's a continuous dialogue going on between state, federal, and the plant authorities. Again, gives you an idea on the extreme side, right side of the size of the centrifuges. It represents, as I said, the state of the art in the technology. Each centrifuge will deliver 350 screws. That's a minimum actually design basis they can go higher. The plant has been designed with safety features required by the NRC. The adequately protect the general public from most severe natural accident disasters possible at the site. And we're not saying this out of vacuum. We have run for the last 50 years, 5, 6 decades, gaseous diffusion plant, so we know the enrichment activity, and we have done very well. There has not been any serious accident of any kind, either through operator error or otherwise, in running our plant. So we're very proud of that history, and we plan to bring the same to the new American centrifuge plant. I believe that concludes my presentation. Thank you.